Good morning, dear students. Last session we have talked about the property called creep. This session we will talk about the deformation characteristics of high strength concrete. So it's like stress strain curves for concrete deformation characteristic in the sense when the stress is applied, how strain will develop in the concrete. So let us talk about compression first. So when you apply compressive stress, how the compressive strain will be in the concrete. So stress versus strain of concrete under compression is initially linear and elastic. Okay? And upon the generation of micro cracks, the behavior becomes non-linear and inelastic. So when you just draw the stress strain curve of concrete, and you will draw a linear line and then a non-linear nature of line. Okay. And after the specimen reaches the peak stress, the resisting stress decreases with increasing strain. So such curve you will be drawing something like this. When I ask you to draw a stress strain curve of a concrete, then we will just draw something like this. So initially it is almost linear, and then it follows a non-linear pattern, and then it is going to break, like breaking point. Okay. So this is a general nature of stress strain curve of concrete. Okay. And that stress strain curve in stress and strain curve, which is initially linear and then we say non-linear. For simplification for our calculation, IS code 1343 2012 recommends parabolic characteristic stress strain curve proposed by Hogstad for concrete under uniaxial compression. Okay, so this curve you can see in the IS code, which is figure 3. If you straight away go to the figure 3, which is stress strain curve for concrete. Okay, so the strain on x-axis and then stress on y-axis, it is mentioned. So first, if you just take the characteristic curve, that means this one. So it is linear and then non-linear. Then this is linearized for the purpose of simplicity. Okay. Then this is characteristic strength, what we call FCK at 28 days. So if you take a specimen and apply compressive stress, you can observe such curve, but as I said, this once it reaches peak, it is going to be the real curve will be something like this. So we will have an idealized curve, something like this. Okay, non-linear and then linear, right? So the parabolic nature of curve is adopted from this Hogstad. Okay. Right. So the strain values, if you observe, 0.002 strain where this parabolic nature of curve ends, and the ultimate strain in concrete is 0.0035. Okay. And how this 0.67 FCK, and what about this one? Okay. So this is the curve which incorporates the size effect of the concrete, because so we will be testing the cube of 150 mm size in the laboratory, and we will be drawing this curve, which is characteristic stress strain curve. But whereas practically we will be using beams of size 300 by 300 and of length maybe 5 meters or 10 meters, something like that. So a concrete which is different from 150 cube size, for that the size effect is being studied, and a factor is uh, multiplied for characteristic strength. So to take care of that size effect of the concrete, okay. So stress strain curve with including the size effect is this one, 0.67 FCK. And now the design stress strain curve is this one, which we will use it for design by incorporating the partial safety factor called gamma m. Okay, the material factor of safety. That is typically a value of 1.5 is suggested by the IS code for concrete, and 1.15 of material safety factor is assumed, suggested by the IS code for steel. Okay. So for concrete, we'll be using 1.5, so that you get 0.67 divided by 1.5, which comes to value 0.67 by 1.5, 0.447. Okay, so or 0.45 FCK. Okay, you can just take that as 0.45 FCK. So that is called design stress strain curve for concrete. Okay, so these are the three curves which you observe in figure 3, which is stress strain curve for concrete, where the first one is characteristic stress strain curve, which is parabolic, assumed as parabolic upon the proposed by the Hognestad, and then a size factor to take care of the size of the member is incorporated with a factor called 0.67, and then the design stress strain curve is obtained by dividing with the material factor of safety 1 point. Okay, so that is how is this one, right? And the equation, if you want an equation form for this, if you want a value at any strain value like 0.001 or 0.0015, if you want, you can get it by this equation. Okay, so for epsilon, strain value less than or equal to 0.002, uh, this FCK into 2 times strain at a particular point by initial strain. Likewise, if you can put it into this equation, that you will get a value. And once the strain crosses 0.002, it is equal to FCK value. Okay. So that is how FC is compressive stress. So this is like FC correction FC. FCK is anyhow characteristic compressive strength, and compressive strain value at you want at a particular point. Epsilon naught is FCK value at 0.002 strain, what we call is proof strain value, uh, and the ultimate compressive strain is like 0.0035. Okay, so this is the equation form for this curve. Okay, like under uniaxial compression for concrete under compression due to axial load, the ultimate strain is restricted to 0.002. Okay, and from the characteristic curve, the design curve is defined by multiplying the stress with a size factor, I said 0.67, and by material safety factor 1 point. So the design curve is used in calculation of ultimate strength. Okay, so the design curve we will be using. And in the calculation of deflection at service loads, a linear stress strain curve is assumed up to the allowable stress. This curve is given by this following equation. Okay, right. And for stress strain curve for high strength concrete, it is for normal strength concrete, which we discussed, up to M60 or M80 grade. For a higher strengths like M100 and so and above, uh, under uniaxial compression, the ascending and descending branches are also steep. Okay, they're very steep curves. Okay, so this is like initial modulus, Young's modulus, initial Young's modulus, or secant modulus. Okay, where the line joining the FCK, the ultimate value, to the initial point, we get secant modulus. Okay, and the stress strain curve for this for grades of 100 and above is given in terms of an equation also for the curve shown, proposed by Thorenfeld, Tomaksevich, and Zensen for the high strength concrete. Okay, and this is the equation to be used. Right, right. The equation for both the branches is applied. The equation given. Okay, so the parameter k models the slope of the descending branch, which increases with the characteristic strength. And to be precise, the value of strain can be considered to vary with the compressive strength of the concrete. Okay, so this is about the grades 100 and above. Okay, which anyhow, just for your information, if you want, you can just have it. Otherwise, what we'll be worried about is only this figure number 3, okay, which will be extensively used in the high strength concretes up to M80 what IS code suggests. Okay, right. Now, under tension, how it will be for a mild steel or for steel, the stress strain curve for compression and tension will be one and the same, because it is elastic and homogeneous isotropic material, whereas the concrete is not up so. So the stress versus strain behavior of concrete under tension is linear elastic initially and close to cracking it is non-linear observed, and a steep curve is observed after the peak. Okay, so this is about the uh, concrete under tension behavior. Okay, the non-linearity is neglected and a linear elastic behavior is assumed as given below. Anyhow, the tensile strength of concrete is almost zero, but anyhow, just for the sake of analysis, if you want, for uniaxial tension, you can have a simple equation which is given as linear. So, stress is proportional to strain, where the Young's modulus is taken care of. Right. So, the analysis of ultimate strength, in case of that, the tensile strength of concrete is usually neglected. As I said, the tensile stress, the strength of concrete in tension is almost neglected. Okay, so this is about the stress strain characteristics of the concrete. For concretes of grades M80 and less, uh, we use figure 3, and for the concrete, even you have an equation form also for that curve. And for concretes of grades more than 100, you can have this curve, and even if you want an equation for that, This is the equation proposed by Thorenfeld and so on. And under tension, you have the curve like linear and then non-linear, and a simple equation by assuming the linear behavior and also neglecting the strength of concrete in tension. Okay, right. That's about the properties of hardened concrete and high strength concrete, which we have studied till date. And just one more small content like properties of grout that is required for the post tension members, where a duct provided for the tensioning of the strands must be filled up with the grout, okay, a cement grout. So how the grout should be? So what is meant by a grout? Is a mixture of water, cement, and optional materials like sand, water-reducing admixtures, expansion agents, and pozzolanas. Okay, so purely it is a mixture of water and cement, and optional materials like if you want to have, you can have it. Otherwise, no. So water to cement ratio is around 0.5. Okay, fine sand is used to avoid segregation. Who want to avoid segregation, fine sand is mixed to get the grout. Okay. What are all properties you require for the grout? One is fluidity is required. Minimum bleeding and segregation should be there. There should be low shrinkage, adequate strength after hardening, and no detrimental compounds should be there, and it should be durable. Okay. So IS 1343-2012 specifies the properties of grout in section 13.3 and 13.4. Just open the IS code with you, which you have, and go for clause 13.3 and 13.4, and you find these properties. Okay. The following specifications are important for preparation of the grout. Sand should pass 150 micron Indian sieve. The compressive strength of 100 cubes of grout made shall not be less than 17 megapascals at 7 days. These are the properties to satisfy these desirable properties that you possess the grout. Okay. So a grout is a simple compound which water and cement mixture, and having optional materials like sand, water reducing admixtures or expansion agents, okay, or pozzolanas. Right. So this is about high strength concrete, which we have been talking about. Okay. So thank you.